हाँ सर, लास्ट टाइम तो क्या कराया था, करंट इलेक्ट्रिसिटी में कराया था ना 12th वाले में, तो आज वो रोटेशनल मोशन नहीं कराऊंगा ना, एक्चुअली दैट बॉय इज नॉट प्रेजेंट, so I will take rotational motion continue tomorrow.
Okay.
Now current electricity topic I have done. I think now in magnetic effect of current I have started or not? Magnetic effect of current.
What's sir?
Magnetic effect of current topic I started or not?
No.
No. Okay. Now I will start magnetic effect of current topic. Tomorrow I will continue with the rotational motion, remaining part. Okay. First tell me, Anisha, the formula for Biot-Savart law. Biot-Savart law. You are knowing the formula?
Sin theta.
Okay, Mohan, I am explaining. After that, you will remember. From next time, you will tell me the answer. Here the formula, that is I is current flowing through a conductor, and this is a small portion, dl length, and here is a point P, and at point P, we want to find the magnetic field intensity. Okay, and theta is the angle from point O to P, and in diagram O is small length, current flowing through the conductor I, and O is dl, small length. This point is clear, everything. This is very long conductor. I have taken only smaller part OA, whose length is dl, current flowing through the conductor I. At point P, we have to find magnetic field intensity. Point P is at a distance r from point O. Okay. So the formula is magnetic field intensity dB at point P is given by mu naught upon 4 pi I dl sin theta by r square. Everything is clear in formula. Theta is the angle between conductor and the point joining the line. Okay. dl is the small length. I is the current flowing through the conductor. R is distance from point O to point P conductor. And mu naught upon 4 pi is constant. What is the value of mu naught upon 4 pi?
10 raised to
mu naught upon 4 pi is 10 raised to power minus 7. 2 into 10 raised to power minus 7. Always remember all the formulas. It is very important. This is the value. Mu naught by 4 pi. Clear? This is the main Biot-Savart law. And with the help of Biot-Savart law, you can find the magnetic field intensity for a state conductor, for current carrying circular coil at any point on the axis of the circular coil, at the center of circular coil. We will discuss all these formula. So now the first is circular coil. Just like electric field intensity, magnetic field intensity also we have to find at a point on the axis of the circular coil. Here, in this case, generally two small portion A dash B dash and AB I have taken having same small length DL. AB length is DL, A dash B dash length is also DL. And from center O to point P, where we have to find electromagnetic field intensity here. Now radius of circular coil is A. So join this part with P. Similarly, join this part of length with P, and you will find that DB1 and here DB dash, DB and DB dash at point P. This perpendicular is drawn. So in this case, you have to learn only what is
Nothing, sir.
nothing. Okay. Now you will see here that this DB cos component get cancelled and DB sin component get added. DB cos alpha, DB cos alpha, both are in opposite direction, DB and DB dash here, but DB sin alpha act on same line, DB sin alpha and DB dash sin alpha. Alpha is the angle which can be written here, alpha. Okay. Here, when you component of DB cos alpha here, see on the board, DB sin alpha here. Similarly, when DB dash component taken, DB dash cos alpha here, DB dash sin alpha here. Here, so cos component get cancelled and sin component get added. And finally, you get the formula. I will write mainly the final formula. Distance OP is taken as x. I will not do derivation here. And point P and distance between DL is R. Okay, small r. That will be same. So this is the rule. Always divide the whole circular coil into different pairs. First pair I have taken AB and A dash B dash. Similarly, you can take one pair here CD, then just opposite C dash D dash. Here, in this way, for every pair, cos component get cancelled and sin component get added. Okay, cos component get cancelled, sin component get added. So total magnetic field at point P will be equal to integration of dB sin alpha. And now dB is from Biot-Savart law, you will put the value. This is very important formula, Biot-Savart law. And using this Biot-Savart law formula, you can find the magnetic field intensity at point P. Okay. And this formula generally comes in this form: mu naught by 4 pi constant taken bahar outside integration, and this is I current flowing through the circular coil. DL is small length. Theta is here 90, so this will be sin 90 equal to 1. Get finished, and R squared taken outside. So I also comes outside the integration because current flowing through the coil is constant. So only you have to integrate length here this thing, and length will be 0 to 2 pi r. Minimum length which we have taken here may be 0, very close to point AB or A dash B dash, and maximum distance between AB and A dash B dash is circumference of the circle pi, so 2 pi r. And after integrating, you will get here mu naught I divided by 4 pi r square into 2 pi r, but you will not take here r, you will take here 2 pi a, because radius of the coil is a. So this is the main formula for electric field intensity, B equal to mu naught I divided by mu naught upon 4 pi I divided by r square 2 pi a. Clear?
Yes, sir.
And now you can put the value of r square. What is the value of r square? Can you tell me from the diagram? In right angle triangle, OP, suppose S, OPS
A square plus x square.
equal to r square. So here you will put value of r square mu naught upon 4 pi I 2 pi a divided by a square plus x square. Okay, this is the main formula. And one thing, that suppose if this angle is taken as theta, so not theta, alpha, one term missing, then we have to integrate here dB sin alpha. Here dB sin alpha, and the value of dB is mu naught upon 4 pi I dl sin theta by r square, and theta is 90, but sin alpha will present, and that sin alpha will go outside, and what will be the value of sin alpha from this figure? So sin alpha equal to perpendicular by hypotenuse, so that is a by r. Okay, is it clear? Sin alpha equal to a by r. Here sin alpha is also big multiplication available present here, because we have to integrate dB sin alpha, not only dB. So sin alpha is a by r. So final formula becomes B equal to mu naught upon 4 pi pi a square, here pi a square into I divided by a square plus x square, and at the place of r, we will write again a square plus x square under root. Means we will not find the answer in form of r, we will find the answer in form of a, radius of coil. Okay, so pi a square, what is pi a square? A is radius, so what you can write at the place of pi a square? Tell me.
Area.
Area of circular coil is pi a square. Okay, so this becomes mu naught upon 4 pi I into a, here divided by a square plus x square raised to power 3 by 2. This is clear? Now this formula is similar to electric field intensity at a point on the bisector axis of dipole. What was the formula at a point on the bisector axis of dipole? Can you tell me? Electric field intensity. Electrostatic.
1 by 4 pi epsilon 0.
Yeah.
P by r square plus a square whole raised to 3 by 2.
Very good. Means 1 by 4 pi epsilon naught P divided by a square plus x r square plus a square. I am writing E equal to 1 by 4 pi epsilon naught P divided by R square plus A square raised to power 3 by 2. Okay. This was the formula. P on the board. P bisector. Here. Now, magnetic field intensity B. Formula is mu naught upon 4 pi. 1 by 4 pi epsilon naught cos constant in electric field. Mu naught upon 4 pi constant in magnetic field. Now, here in denominator, the formula is A square plus X square power 3 by 2. And here in numerator it is BI. What is IA? IA. Here, Anisa,
Yes, sir.
this point is clear.
Uh,
So what you come on conclusion that IA is what physical name can be given to IA?
P.
What is P in electrostatic? What was the P? Naming of
P
P.
was
What was the P? I am asking this P.
the
What is the formula for P? If you have to find the formula for P, what? P equal to Q into
Q
2A.
into L. QL.
That is electric dipole moment. Okay. So remember this formula. P is electric dipole moment. And at the place of P in magnetic, what is the value coming? IA. And every so we can say that IA is magnetic dipole moment. From here, we come on conclusion. Okay. That
Okay.
both formula similar. Both formula electric and magnetic similar. See on the board. So we can write IA can treated as P. Treated as P equal to electric dipole moment. Electric dipole moment. And formula was P equal to Q into 2A. Here, but here IA taken as magnetic dipole moment. I is current, A is area, M is magnetic dipole moment. Okay? Means
Okay, sir.
M is similar to P. Clear? Now, what is the unit of M? Magnetic dipole moment? Tell me from here. Very easy. What is I? I is current. What is the unit of current? Ampere. What is the unit of area? Meter square. So what will be the unit of magnetic dipole moment? That is ampere meter square. Okay? M equal to magnetic dipole moment is dipole moment, unit of M equal to ampere meter square. This is clear, Anisa?
Yes, sir.
What is the unit of electric dipole moment? Tell me, Anisa.
Electric dipole moment. Coulomb.
Unit. You can easily tell me from the formula. Formula is written on the board.
Yes. Coulomb meter square.
Coulomb. Q means coulomb,
Meters.
and 2a is distance, not a square. So only meter. Okay. Coulomb meter. This we have done in electrostatic chapter in detail. The dipole unit of dipole electric dipole moment is Coulomb meter, and unit of magnetic dipole moment is ampere meter square. One thing you note down that in electrostatic topic, Q used in magnetic dipole, magnetic case I is used. This is the difference. Means in case of electric, generally every formula is written in the form of charge, and in magnetism, every formula is written in the form of I. Okay.
Okay.
Now tell me the magnetic field intensity I want to find at the center of coil O, not at point P. See on the board. I want value, what will be the formula for magnetic field intensity at the point which is center of circular coil. Here, now, what will be the formula for this? You can easily find O to P distance. OP distance was equal to X. When point P comes near to center and finally coincide with O, so distance X becomes, what will be the value of distance X?
0.
0 in case of center, because from center you measure distance and there will be no distance. So in the general formula you will put X equal to 0 here. So what you will get formula?
A cube.
A cube mu naught upon 4 pi. Again I am writing B center. This is clearly written as B center, and this formula was for B at any point. B center will be mu naught upon 4 pi, and you tell me IA divided by A cube. Clear? Now again write back the formula of area pi A square. Area A equal to pi A square. So what you will get the final formula for B center? After cutting, tell me the final formula. My point is clear?
Yes, sir.
You will put the capital A, area equal to pi A square. And after that,
I by 4, I by A.
tell me what is again? B equal to B center equal to
Mu naught by 4,
mu naught upon 4
I by A.
I
By A.
but at the center the formula was mu naught I upon 2A. What is going wrong? This formula. 2 Okay. Actually, in this formula, I am using 2. Here, I think the formula was 2.
2.
2 represents not magnetic field intensity. Okay, now first you learn here the formula. I will verify and then tell you. Mainly the formula comes is mu naught I upon 2A. Because I am remembering this formula. At the center of circular coil, the magnetic field intensity B equal to mu naught I upon 2A. Okay? And
Okay.
magnetic field intensity due to a long straight conductor, infinite long straight conductor. These two formula is very similar, and you can learn for reasoning question. Since the second case is this is a straight conductor, and due to this state conductor at point P, we want magnetic field intensity at point P. This is the two portions AB, length dl. I will not discuss the derivation and the formula. Directly you can learn D. This method is used for deriving the formula, but D state conductor you will write here equal to mu naught I divided by 2 pi A. Means similar formula, only pi is introduced. This is clear. Means magnetic field intensity due to state conductor. In question it is clearly written. State conductor, circular coil. In case of state conductor, B equal to mu naught I upon 2 pi A. Clear? And
Sir, B equal to mu naught by 4 pi IA by A square plus X square whole raised to 3 by 2. That formula is for any point from the circle.
this formula B equal to mu naught upon 4 pi IA divided by A square plus X square raised to power 3 by 2. Okay.
Yes.
Here I think 2 appear in the formula, and that 2 get cancelled with 4 pi. So in denominator you will get only 2. Mu naught by 2 I and area pi A square. So A square get cancelled, only A. So this formula is D at center mu naught I upon 2A. That I want to tell. Clear?
Yes, sir.
Here 2 is missing. Perhaps the formula will come here 2. And just I will verify after some time. But first, initially you understand this thing. Next, means you have to learn these two formula. Now my question is the magnetic force acting on a conductor which is not moving. One formula for magnetic force in this case, when conductor is not moving, only kept in magnetic field. Okay? And other formula is for magnetic force, charge body Q is moving and entering in a magnetic field, then magnetic force act on that charge body, and for that charge magnetic force on charge body another formula. Means you are knowing two formula for magnetic force. Can you tell me any one formula for to find the magnetic force?
Magnetic force. Sir, I don't remember.
Okay. No, only you have to learn this thing which I am writing, especially the magnetic force acting on the charge body, moving charge body, and magnetic force acting on a conductor. Clear? Now, tell me the formula for torque acting on an electric dipole. I told you earlier that.
P sin theta.
Very good. Again repeat.
P sin theta.
P sin theta. Very good. Now, that was the formula for torque acting on an electric dipole. Okay. Because I told you, if you will have command on electrostatic topic, magnetic automatically covered. So, torque in case of electric dipole, you tell me formula P E sin theta. Here, P is electric dipole moment, P is electric field, sin theta is angle. This can also written as P cross E. Okay, cross product of two vectors. P is one vector, E is electric field is other vector. Clear this thing?
Yes, sir.
Now, similarly, torque in case of magnetic field, magnetism. What will be formula at the place of P? What you
MB.
At the place of P? First P, after that we will replace E by another quantity. What is E? E is electric field. So this will be removed, replaced by magnetic field. So what is the symbol for magnetic field?
B.
B. Very good. Now E is electric dipole moment. So what is the symbol for magnetic dipole moment?
M.
M. Very good. Just starting the class, I write everything. So MB sin theta and M cross B. Okay. Means in case of torque, electric dipole, you take P and E cross product. In case of magnetic, you take the cross product of M and B. Here. Now, here formula for P was you are knowing. Again, I am writing, repeating. What is the formula for P? Electric dipole
Q
moment.
into 2L. 2A.
Q into 2A. Very good. Now, again, tell me what is the formula for M? Magnetic dipole moment.
Magnetic dipole.
Just 5-10 minutes before I told you. By
I into A.
I into A, capital A. Okay, current into area. And this is for one term. In case of magnetism, you must also know number of terms. If one term present, magnetic dipole moment IA. For n term, number of terms and formula becomes NIA. Simply multiply capital N. Okay? NIA, NAI, you can write. This is the formula for magnetic dipole moment. This is clear?
Yes, sir.
Now, the first question that suppose this is the magnetic field region, north-south pole creating magnetic field, and here a rectangular coil carrying current I kept. Okay, carrying current I kept in magnetic field B. This is clear. Now, length of conductor is suppose L. L equal to length of conductor ABCD. I have taken conductor as ABCD. B equal to small b. I will write not capital B because that will confuse with magnetic field. Okay. So small b with breadth you can write of conductor ABCD. Clear? So this conductor is not moving. This is in rest position. Current I is flowing in the conductor. So magnetic force F magnetic equal to magnetic force acting on the conductor is given by formula will sin theta. You will learn will VIL will sin theta. Clear? What is B? B is magnetic field. What is I? Current through the conductor. L is length of conductor. Theta is angle between conductor and magnetic field. But in this case, theta is 90. So you can write F equal to only BIL. F magnetism BIL if theta equal to 90 degrees. Sin 91. Okay. And this force will be maximum force. Here, F max will be equal to BIL because sin theta maximum value is 1. In this case, the direction of support magnetic field in this way, I am showing on the board, and conductor is at 90 degree with magnetic field. This portion not with. This is clear?
Yes, sir.
Means forearm A, B, C, D, 4 sides. You can say forearm, 4 sides. Side AB is perpendicular to magnetic field. And which side also perpendicular to magnetic field? See on the board. Another side which is also perpendicular to magnetic field.
AB and CD.
AB and CD, very good. And BC, from diagram you can easily see. BC and AB both are parallel to
Okay.
magnetic field. Okay.
Ah,
And in case of parallel condition, angle theta will be
180.
theta equal to 0. So when you will put theta 0, sine 0 equal to 0, and 0 multiply with everything, magnetic force will be 0. Okay. So
Okay.
the reasoning question asks that if a conductor is kept parallel to the direction of magnetic field, what will be the value of magnetic force? Minimum, maximum, maybe between the two, none of these. What will be the answer? Tell me. If a conductor is kept parallel to magnetic field,
0.
force is 0, and this is force is minimum force. Okay,
Ah,
force will be minimum force. Below 0, never minimum, negative cannot. Means magnetic force will be 0 if a conductor kept parallel to the direction of magnetic field. And if we want maximum magnetic force, then we will put the conductor
90 degree.
perpendicular to magnetic field, that is 90 degrees. Okay.
Ah,
Now this was the case when a conductor is taken. Conductor is not moving, conductor is fixed between the magnetic field. Here. Now one thing also works. If a charged particle is moving, see on the
can
board.
only change the direction.